Can you see the screen?
Yes, we can see.
Okay, perfect. So the topic, the title of a presentation is Navigating the AI Revolution, Mastering the Art of Teaching AI in Medicine. So the outline of this presentation will be, I will spend 10 minutes on presenting the motivation for this research and presentation. So I'm going to present several key insights from the labor market. Then I'm going to continue with the main methodology for data-driven curricula enhancement in medicine domain. I'm going to be spending 25 minutes for this, presenting the whole methodology part by part. And at the end, I'm going to show real-world use cases where the competencies extracted from our methodology come into play for the medicine domain. So I'm going to start with the motivation and the insights from the labor market. And for that, I have this picture right here on the right. Basically, the idea for this research started a couple of years ago when we did a research study where we wanted to have a look at the labor market in Slovenia. And we wanted to try to algorithmically obtain the communities which are present in the labor market. So what we tried to do is we used state-of-the-art algorithms from graph theory to try to obtain these communities. And here, a community in a labor market means a set of occupations which are densely connected between each other and more sparsely connected to the rest of the occupations in the labor market. So one of the, we were able to do this. We obtained communities, and one of the communities that we obtained is the medicine and healthcare community. And we can see it right here on the graph on the right side. And we can see some of the occupations which represent this community, such as nursing associate, head lead of nursing associate, health and social care professional, and so on. And the thing is, because of better visualization, we just wrote a couple of occupations that represent the community, and those are the ones with most transitions towards them. So if we have a look at the other communities, there's no clear evidence what they are, but we can see some of the positions. And what we can surely see is that there are a lot of transitions towards the medicine and healthcare domain. And the thing for this is that that other professions who wants to transition towards more upskilling professions, such as the ones in healthcare, are quickly transitioning there, and this means that there's a big requirement of reskilling of workers in the labor market in order for them to be able to meet the job expectations at their job. And one of the things for this high transitions towards the healthcare domain is the rise of AI. And this means that the need for AI skills in the medicine sector and the healthcare sector is rising. So there's a need for AI skills in this sector. So in order to have a better look at this, we also took a snapshot of transitions towards AI occupations, and then of transitions towards healthcare occupations. So these are the two graphs, and here you can see on this graph, so transitions towards AI occupations. Here the AI occupations are colored in blue, and they are chosen from an expert side. So an expert chose which occupations are the leading AI occupations, and this is based on the international standard for classification of occupations. And we can see that both for AI and for healthcare, there's a large transition towards these occupations. And this means that the labor market needs such occupations, and the academic curricula needs to be properly enhanced in order to cover the necessary skills in AI, because there's a lot of AI transitions in the graph. So the academic curricula needs to cover this AI skills and equip the professionals with the AI competences that are in need. But now the thing is, how do we know which are the competences which are required in the medicine sector. So that's exactly what I'm going to present, the methodology for obtaining the right competences, AI competences, which are applicable and in need for the medicine sector. But before I present the exact methodology, here's another study that was done in as part of IJS. This was done in Pennsylvania, and this is a study where we first applied this methodology in the economy and business sector, and we can see that. So what we did is we tried to extract the necessary skills and competences from the labor market only for the positions which are related to economy and business. And what was interesting is that usually in this domain, we see skills which are related to economy and business, but we also saw things like GIS, which is Geographical Information Systems, and pipeline. And here we can see it on this word cloud. And those skills are not really directly related to economy and business. But when we did a deep dive into this, we saw that there's an ongoing activity in the oil industry, and there's a need for economy and business for MBA graduates that are equipped with knowledge in geographical information systems. So this was the key motivation for enhancing the economy and business curricula to have, for example, elective courses in geographical information systems. And from this point, we said, okay, we can, because this was done in USA, we said we can replicate this, the same methodology in Slovenia, and also generalize it towards other sectors, not just economy and business. So we first applied it in the STEM sector, and then we also applied it in the medicine sector. So I'm going to present, I'm going to show some results because we're still in the beginning. In the motivation part, I will show some results from the study of applying the methodology in the economy and business sector in Slovenia. And then I'm going to present, and I'm going to proceed with presenting the exact methodology and its components and its application in the medicine domain. So the results from the first study here in the economy and business in Slovenia, we can see that with green color, we have colored the competences which are covered by the academic curricula. And with red color are the competences which are required or needed or desired by the employers, but are not covered by the academic curricula. And we can see that these are very specific knowledges and occupations, such as inventory management rules, data warehouses, office software, and so on, which were then introduced to the academic curricula to the institutions in Slovenia. And they are in the process of undertaking a revolution in their design of the curricula and syllabi. And we also draw a plot of all of because the insights from the labor market come from the job postings online. We just plotted the job postings geographically on the map of Slovenia, and we can see that there are no local patterns, but this is applicable to the whole region of Slovenia. So there are job postings which are green, which are covered by the competences taught in the academia, but there are also red dots which represent job postings which require at least one competence which is not covered in the academic curricula. So these were the main findings, and now I'm going to present the methodology on how we can enhance the academic curricula in the medicine domain in a data-driven way by following the patterns in the labor market. So this is the main flowchart of our methodology, and I'm gonna present this in a couple of more slides. So I'm gonna come back to this because we are going to go over each component. But right now I'm just gonna give the general picture of what this flowchart means. So we can see that on the left-hand side, we have the academic data and we have job postings. So first, the source of the data, where does it come from? The academic data comes from the academic institutions, of course. So for example, faculty of medicine or other healthcare institutions may be the source for the academic data. And the job postings come mainly from job postings from online sources, such as websites such as Moje Delo, for example, in Slovenia, or LinkedIn posts, and so on. And the idea is that we group these both sources of data into separate clusters, and then we do some kind of filtering and modeling in order to extract the competences which are present in the academic curricula and the ones which are desired by the job postings. So the first part is, of course, text processing, because these data sources mainly come as a text format. So first we do text processing. We eliminate unnecessary characters. We convert all of the text into lowercase, and we also remove the stop words, which do not contain any meaning. So after that, when we have the data sources pre-processed and the data ready for modeling, we use an open source language model, a llama model, which comes from Meta, from Facebook, which is a language model such as the one used in ChatGPT, and we pass the job postings and the academic data into this model, and ask it to generate basically a text which will extract the competences from both of the data sources. But these extracted competences are a bit messy because they come from language models, and they are not standardized. So there might be a big difference between the ones extracted in the academic source and the one extracted from the labor market. So what we want to do further is to try to standardize them and then be able to compare them based on standardized competences. So for that, we use the ESCO taxonomy, which is a standardized way on I think ESCO is short for European Skills, Competences and Occupations, Qualifications and Occupations. And by the help of the ESCO taxonomy, we are able to match the extracted competences to a standardized ones used in a multi-nation way. So they apply what's present in Slovenia can also be applied in other countries. But in order to map the extracted competences to the standardized ESCO ones, we used another language model, which in this case is not generative one, but is a contextual one. And we map the competences into ESCO. And after that, we compare the ones which are provided by the academic curricula. We have a look at them, we visualize them, we try to find some anomalies, and we look at the ones which are not provided by the academic curricula, basically which are desired by the employers in the labor market. So let's first start with the first part, which is of the modeling, which is the llama model. So the language model which helps us extract competences from raw data. Just a little bit introduction to the generative AI field. So the classic landscape in artificial intelligence was that we have one architecture of models per what's said community. And here by community, I mean a type of problem. For example, computer vision, where we have images, or natural language processes where we had sequences. And a couple of years ago, we had different type of architecture of models for all of these communities. But after 2017, after what's known as transformer architecture, all of those communities were replaced with one single architecture. And this is the transformer architecture. And this is the backbone of the modern language models, such as the one in ChatGPT, in Llama, in Gemini, and so on. So we used the Llama model because we did not want to share the data with the providers of the language models. Llama is an open source language model. We used the second generation of the Llama model, which is trained for chat, and we prompted it with the following prompt. We said, which ESCO competences can be extracted from this text? List the ESCO competence with a very short description for each competence. And in this way, the Llama model was able to provide us which competences are present in the text, either in the academic curricula or in the job posting. So that was the Llama model for extracting competences. But now we said that we want to have this standardized. So we used the ESCO. For this, we used the ESCO taxonomy. Here, I will briefly explain what's that. So it's a multilingual classification system by the European Commission. And it provides a link between occupation, qualification, and skills in a structured format, which is machine readable. And we use this skills, this ESCO system in order to map the competences so that we can then do analysis. And this ESCO taxonomy supports curriculum alignment with labor market demands by identifying the skill gaps. And it allows us, when we have the competences standardized, it allows us to do semantic search and compare the necessary text data from the data sources. And this is another diagram display, which is displaying the ESCO standards. We have skills, we have occupations and qualifications, and each of the occupations and qualifications are linked to the necessary skills which are relevant for them. Then the final part of our methodology is the contextual language model, which is SBERT. It comes into play right here. So right after competence extraction from Llama and right before ESCO standardization. So we use the SBERT model, which is short for sentence transformer. And what it basically does, it maps or embeds the extracted competences from the Llama model into a vector space. And what this does is it allows us to give a semantic meaning to each of the sentences or text data extracted from the Llama model, and then we can easily compute similarity between the extracted competences from the Llama model and the standardized one from the ESCO taxonomy. And by computing the ones that are most similar to the ones extracted from the Llama model, we end up with a finalized set of competences extracted both from the labor market and the academic curricula. And here on the right side is a nice chart for this. So on one side we have the general extraction from the language model, and that's on the left side, that's sentence A, and sentence B would be the standardized one from ESCO taxonomy. And then we just pass it through a BERT model, and at the end we perform what's named as cosine similarity, which is applicable for text data, in order to find the most similar ESCO standardized skill. Okay, and now using this methodology, we were able to extract competences in economy and business sector, but then we wanted to apply them into different sectors because we just need the right data. We need the data from the medical institutions, from the academic institutions, and then we also need the data from the labor market. So what we did after this is we applied our methodology to the medicine domain, but because we still did not have the data from the academic institutions, we just applied it on the side of the labor market. So we had a look at what's present in the labor market, and we tried to extract the key AI competences which are present in the labor market in the job postings which are related to the medicine domain and healthcare domain. So we were able to extract a couple of key competences, and we were able to rank them. And here in this table, I'm displaying the 6 necessary competences which are present in the labor market. So those are the first one. On the left-hand side, we have the competence area, and on the right side, we have the description for that. The first one is the AI, artificial intelligence, and machine learning fundamentals. So it does cover just a basic understanding of the concepts in AI and machine learning because it's evolving very fast. Basically, the professionals in the medicine and healthcare sector do not have to fully understand and know how to implement these models, but they need to understand it. They need to have basic understanding because, as we saw at the beginning, there's a lot of interplay between occupations from AI and medical sector. So a lot of the new projects applied in the medical sector also include AI parts, and it's important to know at least the fundamentals of AI and machine learning. So the second one is the medical data processing, because AI and machine learning are hungry for data. And the data comes from the medical side. So professionals on the healthcare side need to know how to handle, clean, and analyze diverse type of data sets. For example, EHR, medical imaging, genomics, and so on. And then, of course, what I think is the most important one is the explainable AI. As we know, the most powerful AI algorithms today are mostly black box, are big neural networks with a lot of parameters, which we hardly understand how they make decisions. So what's important in the medical, in all of the sensitive domains, especially medicine and healthcare, it's important to understand how the models make decisions, not just the models to make precise decisions, but also to be able to answer the question of why the model made such decision or prediction. So explainable AI is a very important skill extracted from the labor market, which is relevant for the medicine sector. And another one are also ethics and legal aspects, which cover GDPR mostly. Then AI in clinical decision making, which covers skills related to how medicine professionals interact with the AI systems, how they can make informed decision making from the models without over relying on them. So still the human factor needs to be in the loop. So that's covered by the AI in clinical decision making skill and competence. And last but not least, implementation and evaluation. Of course, the experts in AI will be able to implement the system, but the real evaluation comes from the medicine professionals, because they are the ones that are intended to use those models and systems, and they need to evaluate the real benefits and the important things that this model does for them in the process. So they have to evaluate the results. They have to evaluate if the model hallucinates or not, and if it's aligned with the domain knowledge. Okay, so these were the extracted competences. But now what I'm going to show is the real world use cases from projects on IJS, where these competences extracted from the labor market related to AI come into play and were basically used in the design of the experiment, in the experiments for the projects, and how they govern the whole process. So we will have a look at two use case scenarios. The first use case scenario is the assessment of ocular blood flow regulation via a head-worn sensor. So before I describe the both use cases, again, I'm gonna just mention this, that the professionals in the medicine and healthcare domain do not have to understand fully the implementation of these methods, but they need to, because they will be closely working with data scientists, they need to understand how these models work, how they are used in practice, even before designing the process, the experiment. And of course, after the design, they have to know how to answer questions such as, why did the model make such predictions? So that's why medicine professionals need to have these competences in order to be able to work with data scientists and AI professionals in such interrelated projects. So this experiment involves a head-worn sensor. And on the right side, we can see two images. One is a graphical one, which just shows how the sensor is placed. And on the bottom side, we see the signals which are gathered from the device, from the head-worn device, which generates the signals. So the idea of this experiment was to see the flow of blood to the visual cortex by looking at a patient who opens and closes their eyes. So we pass the sensor and we look at the signal, and here on the bottom side, the gray line, so it's figure B. The gray line shows when it's on the top, it shows the moment where the eyes are open, and at the gray line at the bottom shows the moment where the eyes are closed. And these are 10 such cycles. And on figure A, we can see one such cycle, the signal of one such cycle of the velocity of PCA, which is necessary in transferring blood to the visual cortex. And the idea of this project was to try, based on this data, to try to find an anomaly or this potential dysfunction of the transmission of blood to the visual cortex. And of course, in order to do this, we fit this data to machine learning models, which then are used as a classification method, which flag if there's a dysfunction. So they just put the red flag if there's some dysfunction at some moment, and if not, they flag that the situation is okay with the patient. Now the idea of the AI competences here, which medicine professionals have to know, is to get the necessary competences in order to be able to interact with such systems. So when these systems are put into practice, the AI, for example, the medicine professionals need to clearly explain why the model made a decision. For example, if there's a flag for dysfunction, we have to clearly explain why the model made such decisions. So that's why explainable AI comes into play, and models such as decision rules, decision trees, and explainability methods from AI, such as SHEP or LIME, need to be enhanced, need to be introduced in the medical curricula so that the professionals can understand how the models make decisions and can clearly not just over-rely on the model, but get an information and then interpret them with their knowledge, with domain knowledge in medicine. And of course, because of the use of biometric head-worn devices, the professionals need a knowledge of GDPR compliance, anonymization, and data governance. And also, clinician must ensure ethical AI integration and AI. Ethical AI integration and regulated medical workflows. And this is covered by the ethics and legal aspects competences. So that's why they come into play. And together, these competences are governing the whole process of doing this experiment. There's another one. So the second use case is the simultaneous ECG and respiration signal acquisition for cardiorespiratory analysis. And here we can see that there's gathering of two kinds of signals. One is ECG, and another one is the respiration signal. And the idea is to do some cardiorespiratory analysis. And on the right side, we have the graphs. These are the signals which are used for the analysis. And these signals are again fed into AI and machine learning algorithms in order to see if there's some dysfunction between the cardiorespiratory system. So in this case, what's important to be aware of is the medical data processing. So clinicians must understand how biosignals are filtered. They have to have some knowledge and competences in signal filtering and cleaning of data in order to ensure structured and reliable AI inputs, because the devices that will be used the medical professionals will have to gather data which will then be provided to AI professionals in order to implement and develop the AI system. But because the AI systems are hungry for data, and there's a rule which says garbage in, garbage out, and if the data that's used as an input to the AI system is not properly filtered, do not contain enough information regarding the process, then the AI output will be, of course, weak, and as it says, garbage in, garbage out. So the output will not be informative. So that's why even before gathering the data, the medical professionals need to have skills in medical data processing. And this enables smooth cooperation between data scientists and healthcare and medical professionals. Of course, here's the explainable AI part, because again, for this use case scenario, AI models are making decisions, and these decisions will not be used as a final decision. So the decision-making process will be, again, with human in the loop, and the information from the AI systems will be used as an information for the experts to make a final decision. But they have to understand how the model makes the decision in order to use that information. So that's why explainable AI come into play together with AI in clinical practice, which is related to decision-making in medicine and healthcare, while there's an AI included in the process. So to summarize, we saw at the beginning that there's an ongoing AI revolution, which is reshaping healthcare and medicine, and the medical education must evolve, must be enhanced in order to meet the new competence demands. So we saw that there's a lot of, we know that there are a lot of projects which are in the interplay between medicine and AI. So in order for medical professionals not to be data scientists, they need to at least be equipped with basic AI literacy, which covers a couple of AI competences, which needs to be included in the academic curricula. One way to do this is through the labor market data. So this was the hypothesis at the beginning, that by using the labor data, we will be able to extract the necessary AI competences, which will be used to enhance the academic curricula. So we saw that the labor market data revealed strong transitions towards healthcare and AI roles, and they highlighted the urgency for curriculum adaptation. We saw that the applied data-driven methodology enables extraction and alignment of the competences using state-of-the-art models such as the LLMs, as on the side of generative AI, and SBERT, sentence transformers models, on the contextual side. So this, together with the ESCO ontology, makes a data-driven method, a framework which can be used for which can be used for enhancing the AI, the academic curricula, in order to meet the massive demand that the AI revolution is making in the medical domain. We saw that there were 6 key AI competences for medicine that were identified, which range from data processing, which covers different types of data sets, such as time series data, medical imaging, and so on. And also some basics of AI and machine learning to know, to distinguish between regression, classification, and knowledge of some explainable AI models, such as decision trees, decision rules, and so on. And also methods coming from the explainable AI sector, which cover methods to explaining the black box models. So methods such as SHEP and LIME, which are used to explain the decisions of the black box AI models. And of course, as a final part, ethics and decision making in AI. So medical professionals need to be aware, because they are working with sensitive data, they have to be aware of the GDPR, and they also have to be equipped with skills on how to make informed decisions and how not to over rely on such systems, but to be able to function in the workflow of human in the loop. We saw real world use cases and how the extracted competences come into play into the modern medicine and AI projects. We saw 2 use cases, and we covered the AI skills which are necessary for signal analysis, diagnostics, and interdisciplinary collaboration between the healthcare professionals and the data scientists and AI experts. And of course, as I said, medical professionals are not model developers, but they must be informed users, evaluators, and ethical stewards of AI in clinical practice. So this is used as a final message, as a key message out of this presentation, that AI literacy is needed and needs to be introduced in the medical curricula, because labor market is moving fast. Almost every week there's a new model dropped by some of the big AI companies, and in order to be able to timely react to these changes in the labor market and AI world, we need to introduce some competencies and elective courses in the academia, which will cover basic AI literacy and will make sure that the medical professionals understand the challenges and the benefits of using the AI in their processes. And of course, I will go back to the slide of the methodology. we saw that here we used Llama model with the the second version of the Llama model. So now we have third and fourth versions of the Llama model. So as a future work, we will try to use the new models and try to improve this methodology and evaluate them with medical professionals. And also we will try to use academic data in order to see if there is some AI competencies which are already covered by the academic institutions, and where exactly is the gap with the skills needed by the labor market. So this methodology will be refined with new methods, new models, and the idea is to make sure that it's in order for it to make change, it's up to date with the newest models and is applied in the right direction. So it's applied in the medicine, healthcare, and also other sectors. So thank you very much for the attention. Below is my contact, and if you have any questions regarding the presentations, I'll be happy to talk about it and discuss it. Thank you very much.
Thank you. Thank you, Victor, for the really inspiring presentation and for guiding us through this important topic with such clarity. And as you mentioned before we closed, we would like to invite everyone to join the discussion. If you have any questions or comments, please use the Q&A section. If you prefer to get in touch with us later, you can always contact us via contact form on our website, aitmed.eu. But we have a few questions in our Q&A section, so I will read everything one by one. So first one is how proposed methodology manage differences in ESCO concept with which can be very broad, while job positing often ask for very concentrated skills. So can you answer that question? If not,
yeah. So to make sure that I correctly understood the question, as far as I understood, the question is about how to align the specific skills needed by the labor market with the ESCO competencies, which are very broad.
Yes.
So yes, I agree. So that's true. And the idea here is that right now the job postings are not perfect, and they will evolve. But the idea is to try to motivate the the employers or the ones that are posting the job postings to make them in a way that they will separate two different kind of skills and knowledges. So one will be more general skills, which they will require from the job seeker, such as the ones which are taught in the academic institutions, and another one will be more specific, industry-specific job skills. And those industry-specific job skills will not be exactly covered in the academia and through this methodology. But here, the idea of this methodology is to try to introduce the necessary general skills of AI into the academia, so that the professionals will be literate in that world. But of course, every industry has specifics ranging from software and very niche knowledge, and that cannot be always covered by the academia. So that's also not the goal of this methodology. The goal of this methodology is to try to cover the general skills which are emerging from the AI sector, which can be and needs to be introduced to the academia and to enhance their courses.
Okay, thank you. That's clear for me. Another one, can you drive any, I am not technical person, so IOI trend, I think this is the correct name, for Slovenia in first, number of people involved employed in medical sector, 2, number of skills present in medical industry overall, and 3, can you name the top 10 skills today for medical industry in Slovenia?
So regarding the first part of the question, I don't have that numbers right now, so I cannot precisely answer that. The data that we used it comes from the ranges from 2010 to 2020, and this covers all of the transitions in the Slovenian labor market. And then with the help of experts in labor market and medicine, we obtained a couple of occupations which are related to medicine and healthcare, and we analyzed them. But we are not, for example, right now I do not have the exact number of medical persons and employed persons in the medical sector in Slovenia. I cannot give that number. I only know that the number of transitions inside the labor market, which means changes of one occupation to another, which was around 400,000 in the period of 2010 to 2020. And regarding the second part of the question, let me just briefly share my screen again. So I will go on the presentation. Regarding the second part of the question, which was related to the top AI competences for medicine which were extracted. So here we can see the top, I think there are 6, 1, 2, 3, 4, 5, 6. So the top 6 competences which are extracted. And the other ones, so which were not that, we only focused on these 6 because they were the most present. The other ones were less present, but they included skills such as cybersecurity, regression modeling, and classification modeling. They were more specific. So these 6 ones were the ones that were most present. But I think the 7th one, which was close to this first 6 ones, was the cybersecurity aspect of artificial intelligence.
Okay, thank you so much. And the last question we have in this Q&A questions is, are the final 6 skills extracted as single skills themselves, or they are a cluster of sub-skills which need to be operational through more detailed curricula?
So the extracted 6 competences are more general skills. So I think they're on ISCO 2 level, so International Standard of Classification of Occupations 2 level. And if we go into more granular level, out of these competences, we can find many more specific competences. And the idea is to try to, based on the skills, the idea is to try to propose this to, let's say, a faculty for medicine, and with the help of them and other experts, to try to design some elective courses, or to include these topics into existent courses in the academia, to try to cover this set of skills so that the professionals are literate on this. So to be precise, this is not like a final set of skills. This is one broad. This is just one broad set of skills which was gathered from the labor market, and they can be made more granular, but by analyzing them on different ISCO level. For example, ISCO 3 or ISCO 4 level, and out of that we can come up with even more specific skills, which are going out of this 6 skills.
Okay, perfect. Thank you. If anyone have any question, comment, we allowed you to turn on your microphone and ask it live. If not, you can always use the Q&A section. And if you would like to contact us in a later time, please go to this website. There is a contact form, so you can always contact us via contact form. Are there any questions? Okay. Scott said that he thanked you for excellent presentation and good answers. We thank you as well. If there is no more questions, thank you one more time, Victor, for presenting the project results. And thank you all for being with us today, and see you next time. Thank you one more time. Bye-bye.
Thank you very much. Bye-bye. Thank you.